All right, today in this video we are going to talk about linear functions. So a linear function is a function of the form f of x equals mx plus b. The graph of a linear function is a line with slope m and y-intercept b. Its domain is the set of all real numbers. So any linear function will have a domain of all real numbers. That will always be the case. Theorem: the average rate of change of a linear function. Linear functions have a constant average rate of change. That is, the average rate of change of a linear function f of x equals mx plus b is equal to the slope of that linear function. So the average rate of change is constant, and it is equal to the slope of the linear function. That's basically what that theorem is saying. Theorem: increasing, decreasing, and constant linear functions. A linear function f of x equals mx plus b is increasing over its domain if its slope m is positive. In other words, if you have a linear function with a positive slope, then as x increases, y increases. It is decreasing over its domain if its slope m is negative. In other words, if you have a linear function with a negative slope, as the x value increases, the y value decreases. It is constant over its domain if its slope m is 0. In other words, if you have a linear function whose slope is 0, then as the x value increases, the y value remains the same. All right, we are going to do a couple problems here, and we are going to practice graphing linear functions. All right, first question is find the slope and y-intercept of each function. Just to make our life a little bit easier, I'm going to put the general form of linear functions next to g of x and h of x, and we're going to use this to find the slope and intercept of each function. First, let's start with g of x. The slope of g of x is, and again our slope will be the number that is multiplying by x, which in this case is 5. And then its y-intercept that'll be the number either adding or subtracting. In this case it is this minus 4, so the y-intercept will be negative 4. You could also express this as a point, and that point would be 0, negative 4. Let's do the same for h of x. The slope of h of x is, and we can see here that we have a negative 2/3 multiplying that x, so our slope is negative 2/3. Its y-intercept is, and in this case we have a positive 4, so it's, or a plus 4, so that means the y-intercept is positive 4, expressed as a point that would be 0, 4. Once you know the slope and y-intercept of a function, you can graph it. So I'm going to start by drawing an x and y axis. I'm going to go a little lower. And we will start with g of x. Again, the y-intercept is at negative 4. So I'm going to go to negative 4, and I'm going to put my first dot. Next, I'm going to use the slope to find the next point. So I know that my slope is equal to 5. And I like to express this as a fraction. And remember, this is basically my rise over my run. And since I have a positive 5, that means I'm going up 5. And since I have a positive 1, that means I'm going to the right 1. So I'm going to just count up 5. 1, 2, 3, 4, 5. And I end up here. And then I go over 1 to get my next point. All right, and I can repeat that process. Starting here, I go up 1, 2, 3, 4, 5, and then over 1, and I get my next point. If you wanted another point, you could also go backwards. You can go down and to the left instead of up and to the right. So I could do 1, 2, 3, 4, 5, and to the left 1 if you wanted another point there. And then just try to draw the straightest line possible. And that will be the slope of the line g of x equals 5x minus 4. Let's do the same for h of x. Again, h of x is equal to negative 2/3 x plus 4. So the first thing I always do is find the y-intercept and graph it. So 1, 2, 3, 4. And I put a point, that's my y-intercept, at 0, 4. And again, let's do our slope. Our slope, that's our rise over our run. And it's equal to, now it's a negative 2/3. What I like to do is move that negative to the numerator, or the top of that fraction. And that tells me if I have a negative in the top, remember the top is the rise, that means I'm going to go down if it's negative. Look, in the previous example it was positive, so I went up. The bottom is positive, so I go to the right, and this is telling me I'm going to count down 2 and over 3 to find my next point. So again, I'll go down 2 and over 3 and plot a point. I'll go down 2 again, over 3, plot a point. We'll do one more in this direction, down 2, over 3. And again, like I said, I like to have some points on both sides of my point, so I want to go in the opposite direction. So instead of down and to the right, I can also go up and to the left. So up 2, to the left 3, and I can plot at least one more point. Again, I'll try to draw the straightest line I can, and I will label my graph with the equation. Okay, so those are my two graphs. And so that was part B. Part C asks us to find what is the average rate of change of each function. Well, the average rate of change of any linear function is equal to its slope. So the average rate of change of g of x is 5, and then the average rate of change of h of x is negative 2/3. So very simple. D is also not too complicated. You can do this a couple ways. Determine whether each function is increasing, decreasing, or constant. You can do this by looking at the numbers or the slopes. So if g of x has a positive slope, right, it's positive 5, so it is increasing. The other way you can figure that out, if you've already graphed it, and think about if I was moving from left to right on the line, would I be going uphill or downhill? I would be going uphill on the line of g of x if I go from left to right. H of x has a negative slope, so it is decreasing. Its slope is negative 2/3. You could also look at your graph. Think about if I was traveling along that line from left to right, would I be going uphill or downhill? You would be going downhill. Right, so those are some of the basics of linear functions, and we will see you in the next video. I hope that was helpful.